So in the previous lecture we discussed the different types of DC motors. In this lecture we will solve the problems on different types of DC motors. So a 4-pole 250 volts DC shunt motor means number of poles are 4, and DC shunt motor means the supply voltage is 250 volts, and if it is a lap connected, that means number of parallel paths is equal to number of poles, should be equal to 4, and 960 conductors, Z is equal to 960 conductors, and the flux per pole is 20 milliweber, 20 into 10 to the power of minus 3 Weber. Determine the torque developed by the armature, that is TA is how much, and shaft torque, useful torque is also how much. And when the current drawn by the motor is 32 amperes, the line current is given as 32 amperes, and the armature resistance is 0.1 ohms, and RSH is 125 ohms, and the rotational losses of the machine is PL is equal to 825 watts. What are the rotational losses? So friction and windage losses. And the problem is given. So first you should draw the diagram of DC shunt motor. The armature winding, and this one is field winding, is connected in parallel with the armature, and I am giving the supply voltage. This value is 250 volts. It draws a current of 32 amperes. The current which is flowing through armature is IA, and the current flowing through shunt field winding is ISH, and this is 125 ohms. RSH is 125 ohms. TA is equal to, we have one equation, 0.159 into 5Z into IA into P divided by A. 0.159 into 5 is 20 into 10 to the power of minus 3. Number of conductors are 960 into what is IA. So IA into P by A. So P by P, this will be cancelled. Now 0.159 into 20 into 10 to the power of minus 3 into 960 into IA. But IA is an unknown quantity. How can we calculate the IA? So we have one relationship between the line current and shunt current. IL is equal to IA is equal to IL minus ISH, and IL is equal to IA plus ISH by applying KCL at this point. So IL is given as 32 amperes. The ISH is calculated like this. ISH is equal to supply voltage will be applied across 125 ohms. So 250 divided by 125, that should be equal to 2 amperes. Now 32 minus 2, the IA value is 30 amperes. What is the armature torque now? Armature torque is equal to 0.159 into 20 into 10 to the power minus 3, 960 into 30. So if you are using calci, then you will get 91.584 Newton meter. Then the back EMF EB is equal to 5Zn by 60 into P divided by A. From this, N is equal to 60 EB into A by P by 5Z5. So A and P both are cancelled. How we can calculate the 60 EB divided by 5Z? 5 is known, Z is known, 60 is, yes, it is a constant. EB, how can we calculate EB? So EB equal to V minus IA RA. V is 250 minus IA. What is IA? Is 30 into armature resistance is 0.1. So that 247 volts. Substitute here then n is equal to 247 into 60 divided by 20 into 10 to the power of minus 3 into the number of conductors are 960. Then finally I got it as 771.87 rpm. So the last torque is equal to power loss divided by omega. So that 825 watts divided by 2 pi into 777.875 divided by 60. Why? Because the omega formula is 2 pi n by 60. So finally I got it as 10.206 Newton meter. How can you get the shaft torque or useful torque? From the armature torque, if you subtract the lost torque, then I get the shaft torque. So TA is 91.584 minus 10.206, that should be equal to 81.378 Newton meter. So check this question. The rotational losses of a machine amount to 825 watts, and when the current drawn by the motor is 32 amperes, determine the torque developed by the armature and the useful torque. It is very simple. Torque is equal to 0.159 into 5z into Ia into P by A, but in this Ia is the unknown quantity and Ia is equal to IL minus ISH, and ISH can be calculated by V divided by RSH, and after that Ia substitute in the armature torque equation, then you will get the total armature torque. Similarly, back Emf is equal to 5Zn by 60 into P by A. From this you can calculate the speed. IB is calculated with the help of this equation, V minus IARA. And finally, last torque is last power divided by omega, where omega is equal to 2 pi n by 60. And finally, shaft torque is equal to TA minus TL. The next problem, a 250 volts 4-pole DC shunt motor, means V supply voltage is 250 volts, number of poles is 4, has 2 circuit armature winding, means number of parallel paths is 2, with 500 conductors. Z is equal to 500. The armature circuit resistance SRA is equal to 0.25 ohms, and the field resistance RSH is equal to 125 ohms, and the flux per pole is 0.02 Weber. Yes, neglect the armature reaction. Find the speed. Speed is equal to how much? The speed of the armature is how much, and the armature torque is also how much. And the machine draws or motor draws a line current of 14 amperes. See, it is clearly mentioned that a motor draws 14 amperes from the mains. So again you should draw the diagram of a DC shunt motor. This is V, IL, IA. The current flowing through the shunt field winding is ISH. The shunt field winding resistance is RSH. Internal resistance is RA. Back Emf is EB. Back Emf is EB. So directly I am writing ISH is equal to V divided by RSH. What is V? Supply voltage is 250 volts. 250 divided by 125, that should be equal to 2 amperes. 2 amperes. If Ia is equal to IL minus ISH, 14 minus 2, that should be equal to 12 amperes. Then the armature torque is equal to 0.159 into 5Z into Ia into P by A. 0.159 into flux is 0.02 webers, the number of conductors is 500, the armature current is 12 amperes, number of poles is 4 divided by 2. Then finally I got it as 38.1972 Newton meter for this problem. What is EB? EB is equal to V minus IARA. Supply voltage is 250, but IA I got it as 12, and the armature resistance is 0.25. So then I got it as EB is equal to 247 volts. Then EB is equal to 5 Zn by 60 into P divided by A. 247 is equal to 5 is 0.02, number of conductors is 500, speed is the unknown quantity, we have to calculate by 60, 4 divided by 2. 4 divided by 2. So 2 2 ja, 2 30 ja, 5 into right, 247 into 3. 247 into 3, then N is equal to 741 RPM. This is our final answer. 741 RPM. The next problem, a 14.92 kilowatts 400 RPM DC shunt motor. So this power is called the 14.92 kilowatts 400 RPM DC shunt motor draws a current of 40 amperes when running at full load. Calculate the full load torque. So 400 RPMs, the solution is speed is equal to 400 RPM. Speed is equal to 400 RPM, and I is equal to 40 amperes. IL is equal to 40 amperes. So the full load torque formula is P out divided by omega. This is out. 14.92 into 10 to the power of 3 divided by omega is 2 pi into 400 divided by 60, 2 pi n by 60. So then finally I got as full load torque is 356.188 Newton meter. Okay, so this is the answer. 14.92 kilowatts is the output power. 400 RPM DC shunt motor draws a current of 40 amperes when running at full load. Calculate the full load torque. Okay, and the next problem is a very very important problem. So you know the difference between motor and generator now. A 25 kilowatts 250 volts DC shunt generator or DC shunt machine has armature and field resistances of 0.6 ohms and 100 ohms respectively. Determine the total armature power developed working as a generator delivering 25 kilowatts output, as a motor taking 25 kilowatts is the input. See, in the previous problem there is a small correction. It has a power output of 14.92 kilowatts. Generally, if this is given 14.92 kilowatts 400 RPM DC shunt motor means we can take it as input power with the voltage is mentioned. If the voltage is mentioned, then you can take it as an input power for the motor, but it is clearly mentioned at 400 RPM 14.92 is a kilowatts, so that's why we can take it as the full load output, right? Yes, what is the solution for this one? So DC, first of all I will draw the DC shunt generator diagram. So the field winding is connected in parallel with the armature. The current delivered from the armature is IA. The current flowing through load is load current, and this one is shunt current. Shunt field winding resistance is RSH. The generated EMF is EG. The internal resistance of the armature is RA, and this one is load. So load. Okay. So power developed in an armature is EG into IA when it acts as a generator. EG is equal to terminal voltage plus IA into RA, where IA is equal to IL plus ISH. IL plus ISH. When it acts as a generator, these terms are the output power. S 250 volts is the terminal voltage, and this is output power 25 kilowatts. 25 kilowatts. So VT is equal to 250 volts, and the output power is equal to 25 into 10 to the power of 3. This power is delivering, divided by, so generally VT into IL, so divided by voltage. If you give the voltage, then I got the load current, then I will get the load current. So this is VT into IL is equal to 25 into 10 to the power of 3, and IL is equal to 25 into 10 to the power of 3 divided by 250. So the load current is 100 amperes. IA is equal to IL plus ISH. 100 plus V is 250 divided by RSH. The shunt field winding resistance is 100. So 100 plus 2.5, 102.5 amperes. Then find out the EG. EG is equal to 250 plus 102.5 into, that is armature resistance is given. The armature resistance is 0.6. So by using calc you can calculate it. So 250 plus 102.5 into 0.6, then you will get 311.5 volts. The power developed in an armature, is equal to EG into IA. 311.5 into IA is 102.5. Then I got the answer is 31.928 kilowatts. This is the power developed in armature. If it works as a motor, IA is equal to IL minus ISH. So this is a motor, shunt motor diagram. So the construction is same, but here we are applying a supply voltage. It draws a line current IA and ISH. The input power is equal to, now it is 25 kilowatts. The line current is equal to, the supply voltage is 250 volts as given in the problem. 25 into 10 to the power of 3 divided by 250, that should be equal to 100 amperes. The shunt current is also same, that is 250 divided by RSH is how much? The RSH value is 100. The RSH value is 100, so this is 2.5 amperes. Now the IA is equal to 100 minus 2.5, 100 minus 2.5, then I got the answer is 97.5 amperes. Then back EMF EB equal to V minus IARA, 250 minus 97.5, armature resistance is 0.6. Then I got it as 191 volts. The power developed in an armature is equal to gross mechanical power, RPM, is equal to EB into IA, 191 into, that is 191.5 volts, 191.5 into IA is 97.5, 97.5, and I got the answer is 18.67 kilowatts. Observe that for the same problem can be operated as a motor and can be operated as generator. It can be operated as a generator. The power developed in armature for this problem is 31.928, and if it acts as a motor, the power is 18.671 kilowatts. Okay, and the next problem is a 440 volts DC shunt motor. So I am drawing the diagram of a DC shunt motor. So this is armature, field winding is connected in parallel with the armature. The voltage is 440 volts. The current drawn from the supply is line current. The current flows through armature is IA. The current flows through shunt field winding is ISH. Same story, RSH. Supply voltage is 440 volts. Armature resistance is 0.08 ohms. And the field resistance or shunt field resistance is 200 ohms. And determine the back EMF when the output of 7.46 kilowatts. So output power is equal to 7.46 into 10 to the power of 3 watts. At efficiency is equal to 85%. 85%. See, efficiency is equal to 0.85. So why it is giving an efficiency means, you know that efficiency is equal to output power divided by input power. So from this you can calculate the input power is equal to output power divided by efficiency, 7.46 into 10 to the power of 3 divided by 0.85. So 7.46 divided by 0.85, I got it as 8.7765, 8.7766 kilowatts. This is the input power. As I am obtaining the input power is like that. Okay, so this is the power input is equal to V into IN, that is VIL. So VIL is equal to 8.776 into 10 to the power of 3. Then the line current is equal to 8.776 into 10 to the power of 3 divided by supply voltage is how much? That is 440. So finally I got it as 19.9465 amperes. This is the line current I am getting. So how ISH is calculated? ISH is equal to V by RSH. V is 440 and RSH is 200. That should be equal to 2.2 amperes. Then IA is equal to IL minus ISH. 19.9465 minus 2.2, then I got it as 17.7465 amperes. Then finally EB equal to V minus IARA 440 into minus 17.7465 into 0.08, that should be equal to 438.58 volts. And these are the different types of problems. And the next important problem, a 4-pole DC motor has a wave connected. So write the given data. For a given data you will get 1 or 2 marks. Number of poles is 4 and the wave connected is number of parallel paths is 2. 77 slots are given. The slots are 77 and a slot containing each slot, in one slot 8 conductors are there. So total number of slots is 77. In one slot 8 conductors means total number of conductors is 77 into 8. The 77 into 8, the value is 616 conductors. 616 conductors. The flux per pole is 30 into 10 to the power minus 3 Weber. The armature resistance is 0.15 ohms. When the motor is connected to 250 volts supply, that is 250 volts supply, armature draws a current of, see here is given as the armature current 70 amperes, driving a load of, yes, load power or output power is 15 into 10 to the power of 3 watts. Okay, from this calculate the back EMF. EB equal to V minus IA into RA. V is 250, IA is 70 and RA is 0.15. Then I got it as 239.5 volts. I got it to 39.5 volts. Then first of all, what is the first question? He is asking what is the first question? Speed. So from this back EMF EB equal to, we know the formula of IZN by 60 into P by A. So 239.5 is equal to 5 is 30 into 10 to the power minus 3. The number of conductors is 616. The speed we have to calculate 60 divided by number of poles is how much? 4 by 2. So from this N is, I got it as 388.798 RPM. The second problem. So second problem what he is asking, second question, TA is equal to 0.159 into 5Z into IA into P by A. 0.159 into 5 is 30 milliweber. Check that what is the 5 value? Is 30 milliweber. Total number of conductors is 616. The armature current is 70 amperes and 4 divided by 2. Then I got it as 411.7656 Newton meter. And what is the third one? Shaft torque is equal to power output by omega 15 into 10 to the power of plus 3 divided by 2 pi n by 60, 388.798 by 60. So then I got it as 368.416 Newton meter. So these are the problems on DC shunt motor. These are the repetitive problems. So I think you understand, guys. Thank you.